Thank you for being here. That's of course your task, to present your thesis, Mohammed. And you have 20 minutes for your presentation, and then we will have some questions from the jury members. Also the public can ask some questions if they like. So please, the floor is yours.
Good afternoon. Today I will present my master thesis work, Historical Evolution of Value Climate and the Environment in Belgium, based on stable isotope analysis of a stalagmite from the Answer scale. First of all, why we study value climate? From the fact that the past is the key to the future, which we should to learn lessons from the past to predict the future. And since the age of Earth is about 4.6 billion years, and only the length of climatical records is about 150 years, a question here highlighted: how do we know the climate change before this period of 150 years? And only geologists can answer this question by reading the natural archive like ice core, marine sediments, lake sediments, and others, and speleocenes. In this thesis, we use the speleocenes as a powerful tool for reconstruct the value climate for more reasons. Some of them, speleocenes, are well preserved and can be well dated by uranium serial dating and other techniques like carbon-14 layer counting. Speleocenes will have well-defined stratigraphic verified speleocenes may show a variation in chemical and isotopic composition. So, where we can find these speleocenes in Belgium? We can find it in the southern part of Belgium, where the middle Devonian limestone contains a large number of caves. One of these caves, the Answerless cave. Inside Answerless cave, I met Ms. Brozarbin, and I asked her, could you please, Ms. Brozarbin, tell me about the value climate and environment in Belgium, since I cannot speak Dutch or French? And immediately she kindly replied me, yes, Muhammad, I have a language you can understand. It's the isotopic language, so follow me. I followed Ms. Brozarbin's instruction, and she mentioned that Dr. Sufi Verhegen took a core of 2 meters from me, and I know you have no time to study the whole core, so you should to select a part of this core, and I already selected a part of 23 centimeters. Regarding to the calcite analysis, you should to use 2 different strategies. The first strategy is the low resolution strategy in order to get a general view about the isotopic composition of that part, and in which we applied a continuous line of 5 millimeters. And she also said, if you find something interesting in this low resolution profile, you can go again through me in a high resolution profile to check. And for low resolution profile, we analyzed oxygen and carbon isotopes using our old technique in the geology department. And for the high resolution, we used the new technique, automatic technique, no manpower, and other things. And she said, don't forget to analyze the water feed mean, the drip water, and I analyzed the oxygen isotope for drip water using the continuous flow mass spec. And coming after performing these instructions, we have this output of Ms. Brozarbin. And clearly seen here in these 2 profiles, we have low resolution profile and high resolution profile. We have a clearly variation in isotopic composition here in low resolution and high resolution. But still, we don't know the date of this variation. We know the distance, and we should to convert this distance to time. And we used a simple interpolation to do this, knowing the age of top and the bottom, applying this equation to get the time instead of distance. And now we have time, we have variation, but we don't know which factors control this variation. And we start to put hypotheses and test this hypothesis. So for oxygen, there are 3 possibilities: temperature, or rainfall, or the combination of both. For carbon, vegetation type or vegetation unbound, or others like cave ventilation, but here it's not our case because we speak about annually variation, not seasonally variation like cave ventilation. So starting to suppose that the temperature is the main control for the oxygen isotope, the calculated dependence of temperature in calcite in the stalagmite equal 0.34. This value coming from the combination of different fractionation between the rainfall and temperature 0.5 with fractionation between calcite and water 0.24, which gives this value of 0.34. And we calculated the average, we calculate the range between the maximum oxygen isotope and the minimum oxygen isotope for our low resolution profile, and we found that it's 0.33 per mil, and this difference required 4 degrees, and this 4 degrees is too large according to our knowledge of value temperature. When we observe it here in this figure, we can find the maximum temperature difference during the last millennia is about 0.5 degree or something like this. So we suggest that the delta O can be used as a rainfall amount proxy when the dry condition with less equilibrium and less delta O with less negative values, and the vice versa for wetter condition close to equilibrium and more negative. Coming to test hypothesis of carbon. First of all, we found that values of carbon isotopes in bromazepine ranged from -11 to -8 per mil. And if we check this figure, we can find under the C3 type, the carbon in calcite ranged from -16 to -10, in average -13. And for carbon 4, it's in average 0. So our values in agreement with C3, so there is no C4, so we can't use this for vegetation type. We use as a vegetation amount because we can consider the decreasing and increasing of these values depend on the intensity of vegetation cover above the cave. And here we can find this relation and inverse relation between when the carbon increase, the vegetation amount decrease, and vice versa. An additional argument for our hypothesis, for our suggestion that the positive correlation between both carbon and oxygen, it's logic when the conditions will be wet, the vegetation cover increase, so we give an additional argument for both. And now we know the reasons, we know factors, we know time, we know that we have the variation, and we will start to interpret that on our low resolution profile. And here we observed 3 dry periods before 1610 and around 1710 and around 1708, and a distinct wet period here between 1725 and 1770. And here we have our interpretation. But the interpretation without validation is nothing. So we should to validate our interpretation, and we start to validate it with a historical document to wheat price. Wheat price in different countries. As known or a logic, when the wet condition assigned, the vegetation cover increased. So if the vegetation available in the market, so the price is cheap, and vice versa. So here, to correlate our wet peak with the prices here in France, and we use the France because it's the country most nearest from our cave, we can find here that wet period correlated to the cheapest prices. And for dry period here at 1000, before 1610, expensive prices. And here also for 1780 expensive prices for that cave of France here. Here is the cheapest one, here the expensive one, and here also the expensive one. An additional confirmation to our interpretation, Kington, a climatologist from Cambridge University, make a book about this period of 1780, and he observed that this period several summers were drier and severe winters in this period. So our high resolution going to check this part, the 4 centimeter part of including this period, and we find that a peak of oxygen, a depression peak of oxygen, a high isotope values of oxygen indicating a dry period here, and for carbon, a high isotopic values indicating a crop failures or decreasing in the precipitation, and 2 levels of humidity. Here, the wettest period, and here the intermediate period between the driest period. And a question here comes to the surface. Which climate force affect the wet condition and the dry condition in Europe, especially in Belgium? And we get this theory of North Atlantic Oscillation. The North Atlantic Oscillation Index is defined as the normalized pressure between the high pressure station at Azores and the low pressure station at Iceland. And we have 2 NAO index, positive one and negative one. In the positive case, here the high pressure at Azores grow up stronger than the low pressure and pushed the North Atlantic Oscillation to go to the North Europe where Belgium is located, and the wet condition assigned in Belgium and the dry condition in the Southern Europe where the Mediterranean basin, and vice versa for negative when the 2 systems are weak. The North Atlantic Oscillation going easily to the southern part of Europe assigned wet conditions in the southern Europe and the dry conditions in the northern Europe where Belgium find. So we can conclude positive NAO index correlated to wet condition in Belgium and negative NAO index correlated to dry conditions in Belgium. So we should to correlate our result now, our isotopic composition, which indicate wet and dry periods, with this index, and we find that the 3 levels of humidity, the wettest level correlated to the positive one, which is indicating the same period, the same purpose, wet conditions, and the driest, the third one, the driest one here in our isotopic values, correlated to the negative one, which give an indication to the driest period, and the second one intermediate between the wettest and the driest periods.